Good afternoon, ladies and gentlemen, and welcome to today's webinar, Makings of an Effective Job Shop. The Key is Knowledge, sponsored by Epicor. All lines have been placed on a listen-only mode. If you would like to submit a question or comment at any time during the webinar, you may use the chat box located in the lower left-hand corner of your screen. If you should require assistance throughout the conference, please press *0 to reach a live operator. At this time, it is my pleasure to turn the floor over to your host, Drew Locher. Sir, the floor is yours.
Thank you, Karen, and thank you all for joining us today on this webinar. Greatly appreciate your time. We have a lot to cover, so we're just going to really get right into it. Before we get into what we typically do in a job shop environment, I'd like to take a step back and just talk about what makes job shops different. Obviously, there's a high product mix, and that typically requires a lot of frequent setups, changeovers of equipment. There are variable product routings. Products are making their way through the shop differently. There are variable process times. The other concern that job shops convey to me is that there's the unpredictability of demand. There's a lot of demand variability, which makes capacity loading a challenge. What that really means is that job shops, and I could argue that all companies really need the following: a high degree of flexibility, excellent information quality, ability to capacity plan, shorter and shorter lead times throughout their processes, and that's not just in production but also the pre-production processes, and outstanding workplace organization and visual management. Really the highest level of understanding of the lean concepts. And I say that because all businesses really need to adapt lean concepts to their circumstances. Job shops in particular have to really adapt the concepts. And so for the most part, these are applicable to all businesses, though the information quality is much more important in a job shop because we're not doing repetitive manufacturing. So the information quality has really got to be there. So we're going to hit on most of these today, spend a little bit of time more on a few of them that are a little kind of unique, like ability to capacity plan, and less time on some others, like 5S and workplace organization. A few friendly words of advice, though. It's very overwhelming. It's easy to get overwhelmed, I should say, when everything's different, everything's varying. So what I often suggest to job shops is to focus on the similarities between the jobs. And what they'll find is that there's a lot more similarities than they recognize. And that seems to help people. It seems to help them kind of get a hand around their business. So don't dwell on the differences because your business is complicated enough. So we like to try to keep things as simple as possible. And remember this, and this is tied in with the title of the presentation, experience is data. And job shops have tremendous experience. The people within them have tremendous experience and knowledge, and we can use that to create the data that we need to do the things that we need to manage our business, such as capacity plan. But there's other benefits as well. So remember, experience is data. So going over the need for a high level of flexibility, what does that mean? Certainly, job shops need to be able to conduct quick setups or changeovers, ideally in 10 minutes or less. And in the lean toolbox, as we'll see on the next slide, there's a methodology for that if you're not familiar already. We need to cross-train our human resources. So that gives us maximum flexibility to be able to move people about based on the actual demand. And once again, the Lean Toolbox provides us some techniques for that. It's called Job Instruction, or JI. It's part of TWI, the Training Within Industries, which has been called the foundation of Lean, which is, unfortunately, though, very few people are aware of TWI and JI in particular. Yet they often have been practicing Lean for some time. So I would strongly encourage all organizations and all industries to familiarize themselves with Job Instruction JI as part of the TWI methodologies. Right-sizing tools and equipment seems to be helpful for job shops to give them maximum flexibility. Instead of buying large monuments, maybe several smaller monuments to give us flexible capacity, ability to maybe move equipment, that kind of thing. And then also timely decision-making. Once again, in the Lean Toolbox, there's a concept called pull systems, which is really a decision system. I'll talk about this later today and show some examples. But think of it really as a decision-making process. And time is valuable, and we don't want to lose time, so making the proper decisions in a timely manner is very important in organizations. So a really effective job shop is an agile organization that can turn on a dime. So just to talk a little bit more about quick changeover, if you're not familiar with the concepts, I would strongly recommend getting familiar with these. The key concept is externalization. To kind of the counter of that is internal. These are internal processes or activities that are performed when the process is down. You stop the machine, you stop the process, and you start changing over. That's on the top line here. And all the activities tend to be done while the process is down. What we typically do is look at those internal processes and identify which ones can be done externally, either before bringing the process down or after the process is started back up. And usually up to 50% of the opportunity lies in this area, just externalizing, as we would say, the various activities that are done internally now to the setup process. And then the last step is just streamlining, both internal and external. And that typically requires, some maybe technical solutions to that, some physical changes to the equipment, fixtures, tooling, and so forth to speed things up a bit. Sometimes teaming approaches can help speed things up. Think of like a pit crew. We actually use that analogy, the pit crew ballet. But most of the opportunity lies in the externalization concept. And all that means is basically to reduce changeover time, we just have to be better organized, knowing what we need and when we need it by, and doing that ahead of time or after the fact. So, again, not much time to get into this in more detail, but there are great reference books and such if you're interested on this subject. Excellent information quality, and that goes all the way back to the quote process. Understanding the true customer needs, not just the price, but the technical quality, delivery expectations of the customer. And this is why in job shops, the sales role is so important, and starting at the very beginning to extract the proper information. Too often we have seen that information coming in from sales or from the customer directly themselves, often through a quoting process, is incomplete, inaccurate. When this is pointed out, very often the response is, we'll get that caught up later, and it just doesn't seem to happen. So what we need to do is apply the lean concept of quality at the source throughout the process, going all the way back to the quoting and estimating processes. So looking at those in various organizations, you can do this for yourself. Actually have a request for quote, give it to two different people in your organization, see what they come up with. And very often there's some important learning there. There's a lot of variability in those processes. And much of it is because of how we interpret information, or the fact that some information is just plainly lacking. And we have to do a better job kind of drawing a line in the sand at the very beginning to get the proper information. And that means, working more closely with your customers to extract that, understanding their true needs and putting it in terms that the rest of the organization can use. Of course, as we take the order, we need excellent information quality there. Because if you don't have the right information from the beginning, you're basically fighting an uphill battle. The information quality of the job packets, or whatever you want to call them, the information that's released to production has to be pristine as well. Otherwise, we could be doing the wrong things. And all the way through to the invoicing process, if you want to take it that far. So a lot of folks tell us, how accurate can we really be? We're a job shop. We don't do repetitive type of items. And I'll make that statement again, experience is data. You have a lot of smart people, a lot of experience in your organization. It's just a matter of getting that information in a place that others can tap into, that tribal knowledge that people have but just don't properly share. And that actually is what we use to create standard work instructions for anything, including office processes like order processing and quoting and estimating. We extract out that tribal knowledge. It really goes back to that job instruction or JI methodology I mentioned earlier. Okay? So I think from my experience, too many organizations tend to throw their hands up and say, there's not much we can do in this area, and I think otherwise. Ability to capacity plan. This is another one that a lot of organizations really struggle with, and understandably so. Couple key points here is focus on the expected constraints only. Don't worry about all of your resources, just those that your experience tells you can become constrained in any significant way. Another bit of advice, don't confuse precision with accuracy. Even if you're just in the ballpark, and in the ballpark might be 75% accurate, that's usually good enough, because there's other techniques that are going to be put in place to tell you very quickly when your plan is not quite right. We'll see some examples of this later. In the lean toolbox, we have what we call plan versus actual boards and other techniques. Doesn't have to just be a board. But that plan versus actual tells us sooner than later that we weren't quite right, and then we can make more timely decisions as a result. When we do capacity plan, there is a tendency to overlook the office processes, whether it be designing or production preparation. Those are resources that in some organizations can become constrained and therefore must be part of our rough cut capacity plan. And once again, there's an important role of sales here to provide us with as much information as possible, and also later making use of this information to better establish customer expectations. Generally speaking, with capacity planning, keep it simple. Just focus on those key resources, a group of similar resources that you know from experience can become constrained. So some things to think about is, what is the appropriate measure of demand? And over, 30 years of doing this, I've seen it typically be hours, but I've actually on occasion ran into other measures of demand that directly relate to the workload of the constraint. I've seen dollars, the actual dollars that we whipped up as part of a quote, be used in high-end kitchen. I remember custom kitchen making in a production company. And they used dollars. They showed me the relationship between the dollar value of the order and the process time or the workload on the constrained resource. Another example, if we have time, we'll see a little bit of a case study later, was a stone fabricator. And after some conversation, it became apparent linear feet of treated edge was directly related to their constraint, which was the finishing area. And that data was right on every quote, and we were able to use it. And that was a pretty precise number, but there was a lot of still variability in that based on the type of stone and that kind of thing that the finisher was dealing with. But it got us close enough to so we could properly capacity plan. So this information is often available, all the way back to the quotation process, and we could tap into that if we get the order. So that information is there very often. Once the demand is determined, the variability demand can start to be understood, and we can start figuring out what to do with that when we encounter this variability, which is the purpose of the next slide here. So you can do this several ways. In this example I have is in weekly buckets, but you could do this in daily buckets. It's up to you. And you would repeat this against, for each of the key resources that, again, are known to become constraints. So we would have demand coming in, and we would start filling the buckets, literally. And we would keep adding the work until we got to a certain level. We always say don't load at 100%, load at something less. How much less we'll talk about briefly, but it's really up to, we typically go around 85%. And this allows us, again, some flexibility. So then as demand continued to come in, we'd fill up the next bucket and the next bucket. And then what this starts allowing us to do is to start making some early decisions to try to level load the key resources. So like in this example, I might take the demand in week 4, if the demand in week 3 continues to be low, move that demand up accordingly and try to level load. And of course, this is a dynamic thing that's happening maybe every day in some businesses, or at least every week. It really depends on your lead time expectations of your customer and some other things. So this is if you're kind of scheduling on an ASAP, as soon as possible approach. But you can do this exact same approach if you're in a project environment where the customer is setting dates. And I worked with fabricators, metal fabricators that are driven by some big project that the customer is doing, and they set the dates, the customer. Same concept of filling buckets, loading to less than 100%, and then monitoring when demand is exceeding the available capacity overall or in a particular period, which again allows leaders, managers to start making more timely decisions with this knowledge in hand. Unfortunately, a lot of job shops I encounter, when I ask them, well, what's your backlog, they really can't give me a good answer. Sometimes they can give me dollar backlog, and then we start talking about, can you translate that to demand on your resources, and they sometimes, most of the time, cannot. And so they're really running blind with regard to capacity, demand versus capacity, and that's not a good position to be in, as probably most on the phone, on the call here or the webinar realize. Then what we do is fix the schedule. Again, we can fix this a week, we can do a day or several days. You have to decide what's right for your circumstances. The rest we can be flexible in. And this is where sales has to understand, too, that when it's fixed, it's fixed. We can't be dropping, last-minute orders in, that kind of thing. We can in weeks 2, 3, and 4 in this example, but week 1 is fixed, and we want to keep it that way. So we're not adding unnecessarily a lot of variability to really everyone. That would not be necessary. So then once we have the schedule, we release a standard amount of work to the production each day, and to that fixed schedule. Within that fixed schedule, we can sequence in some clever ways sometimes to help everyone. You'll see a little bit of example of that later in the webinar. But that's basically it. And once again, we don't load at 100% capacity. This allows us some flexibility. We can handle some rushes maybe, but not all. This handles maybe problems that arise in a job, maybe quality issues or downtime in production. We don't want to cut this too tightly and schedule it 100%. Because the fact of the matter is we can always move forward. It's just a matter of, if we move forward and can't meet the plan, we're going to have upset customers. So that's usually the issue there. So with this knowledge of a means of ongoing monitoring of demand versus capacity, managers can make better decisions. They can monitor that job queue, in the middle here, and not just level load production to a large degree. Nothing's perfect, as the graphic shows. There's still variability there. But we can look at when there's been maybe trends in demand changes up or down, where there's sustained increases in demand or decreases that may trigger some decisions on maybe staffing, maybe authorizing overtime to meet short-term increases in demand, maybe the use of temporary resources during those periods, or conversely in slow periods, not using temporary resources, that kind of thing. So it's all about getting that visibility. Once again, sales has an important responsibility here, not just following this fixed schedule, but making sure that changes to due dates is minimized in that fixed schedule horizon, and is in line with whatever excess capacity has been designed into the system. What I've found in many job shops is that this information and this visibility to it can be used by sales to target cell available capacity. Because remember, you would have that graphic for all the key resources that can become constrained. So there's often maybe 2, 3, 4 of those, including maybe the office resources like design or engineering would maybe have their own. With that information, sales might be able to target cell available capacity, sell that those jobs, maybe close those deals, those quotes, that knowing that we have an open capacity in a certain period of time. Maybe get a little more aggressive with closing those deals, those opportunities. Moving on from capacity planning, short lead times throughout is always good advice. This includes order processing as well as the production process. And what we try to do here, there's a lot of things, but one of the things we try to do in terms of the information availability is to monitor how we're doing, this plan versus actual that I've mentioned at least twice already. In lean terminology, we call that management time frame or pitch, frequency. And we want to look very frequently at how we're doing and be able to make adjustments in a timely manner so we don't lose valuable and limited time. Very often I see the job shops, really all organizations, don't have a proper frequency of reviewing for their business. We have like a daily production meeting. Okay, but what happens within the day? We could be losing upwards of 8 hours if we're a single shift, maybe 16 hours of 2 shifts, if all we do is get together once a day and really look at performance. There's a great benefit of reduced time frame, looking at performance in simple ways, I must add, maybe even hourly, to monitor that performance and make quicker decisions. It adds a pace, a beat, a rhythm to the flow of work, and that in of itself will help flow. Of course, we can do the physical stuff and changing layouts and things, both in office and production areas, and that certainly can help flow as well. I have an example here of an office cell in a job shop. And this is the before picture where you can kind of count up every job went through about 9 different departments, really, different functions, and maybe 9 not including sales. And as you can see from the graphic, it put a lot of miles on. And we ended up going to this model. Actually, there's 2 office cells. Some people might call these pods. And what we did is we not just brought the functions together, but we combined certain functions to be conducted by a single role. I think we called them a conductor. And there were slight variations to this, whether the customer supplied the design or we were creating the design for the customer. And then this was duplicated throughout the office. I forget, ultimately maybe a dozen or so of these cells, which was sufficient to meet the overall demand on the business. But that's certainly, I think most people would agree, this graphic is a lot better than that graphic, which, if I recall, put on about a half a mile every order. And yes, the information was traveling electronically, but every handoff you have is the potential for queues and lost time and quality issues, all of those things. That an improved flow through maybe the application of an office cell or a production cell can truly help. Someone was asking what EPP is, electronic prepress. That was actually a print shop example. So here's just a simple example of a sheet metal fabrication cell bringing together different processes like a turret with a brake press with a time saver. And, there's opportunities to apply such concepts even in job shops. I always say it sometimes just makes sense to have it just makes good sense to have certain equipment next to other equipment. It might not work for you 100%, but that's okay. All right. This example here, again, knowledge is experience is data, and that's knowledge, and we can use it. This was a company that made 2,000 different SKUs of surgical instruments and so forth. And, we sat with folks and basically extracted what they knew about different jobs that they ran. And we found that there were a lot of families, groups of similar products that shared similar processing steps, and maybe even the times were very similar. So out of 2,000, in one cell, we were able to run about 250 different products. And this tool is more important than the story. The tool represents the information that these folks had that just didn't really use. So we would create these sheets, these process sheets for a product or group of similar products. Sometimes it could be a dozen products that one sheet would apply to. And, we would kind of put together here a list of all the steps, the times to perform those steps, and these were similar products, the times were similar. And then it gave us, we were able to calculate what the different stamping scenarios were for the different products at different levels of demand, because the demand of these products could vary based on the actual order of the customer. So even though we made the product in the past or we made something similar, the demand could vary. So this is showing like for 200 of this product, we would need about 6 people. And not only that, it would tell us how to balance out the cell that was designed. These are people. And using this data in the circle here, the oval, it would tell the lead or the supervisor not just how to set up the cell, but also who needs to be doing what in order to promote balance and flow. The lower left is a graphical representation of the cell, and as you can see, this was a mixed model, so we didn't use all equipment. Some equipment we bypassed because that particular product didn't need it. The equipment was set up differently for different equipment. So this actually shows how the machine should be set up and so forth. So what happens is that people are able to very quickly set up, going from one product to the next. This particular cell, if I recall, was back in the 1990s, so my memory's not all that great. But if I recall, we might do 24 different jobs, maybe more in a single shift, and we could transition from one to the other with modest interruption of flow, maybe 2 minutes at the most, because of this process sheet. So this was one of a small playbook of process sheets. And it helped the folks be able to switch over and get organized, for every job that they needed to run. And again, this information existed in people's minds. I just sat there for hours upon several days, really, to extract that information from people in order to create this sheet, which is really just becomes a very powerful tool for the organization to use. So once again, experience is data, and knowledge can exist in organizations, just needs to be used. Some other things about continuous flow, we don't expect you, if you were to do some sort of cells or flow systems, you probably won't get the ideal of one-piece flow. That's okay, and it probably won't work for all the jobs that you run. I usually say if you can do it 70% of the time, you're doing great. So don't worry about those things. You can make your business 70% better, or easier, I should say, then go for it. So another good things result besides reduced time, better communication, improved quality, cross-training becomes much more possible. You get a better sense of teamwork because it is a single process, single team concept. All those benefits as well. If you can't do the ideal of one-piece flow, and a piece can be a job, an entire job, or it could be a set of parts for a job. What's the next best thing? And that's pull systems. And we can do sequential pull systems in job shops, which can help control the flow. Once again, think of the pull system as a decision system. There are rules that we would give to the team members that they can follow in time, so they're making better decisions of what to work on, what next to work on, what to get ready for in near real time, which is very helpful, again, for the organization. So you have this fixed schedule that says, okay, work from here, but then within that, we're going to release the job during that day, the jobs based on actual demand of the production process or the office process if we set it up for that. Generally speaking, the desired sequence is first in, first out, but sometimes we'll go off that and do some other sequencing within that fixed schedule to help the shop out. So here's an example, graphical representation from a sheet metal house. I've done this numerous times with sheet metal places. And we would set up these areas between the resources. In this case, we're going from the laser to the brake to the welder, and you can extend this on if you'd like, but we'll just focus on these three resources for this example. And we would establish some maxes to the queues. And you really want to establish it based on time. How many hours does it represent? In this particular example, we're hoping to get through from the laser through the welders within 1 day. So for me to do that, for us to do that, I can't have more than 4 hours of queue in the two queues. If it's a 1 day, 8-hour shift, we'll assume for this example. And different colored boxes here, cubes, are the different jobs that are running through the system. And we might even put them in, for the queues as well, because we don't want the pipeline to run dry, so to speak. So how this would work is, if I'm the laser operator, and I've worked with numerous laser operators at the beginning of a process, and they become like the quarterback. They're making all the reads and the right decisions. If they see that the brake is at its max of 4 hours and the welder is at its max of 4 hours, then they wouldn't just keep pushing work in. The laser would stop, maybe do other work, maybe even go help the brake or the welder if we cross-trained, and I've done that in some companies. Then when it got back down to, say, the min, the laser would make sure they're back up and running again by that point to keep the pipeline full. It could be that the brake press is full, but the welder queue is not. It's not at its max. The laser operator could look at the schedule, that fixed schedule, and start going into a different sequence if maybe there was a laser and welding job that didn't require any forming on the brake press. And you can just keep going on with the scenarios, but basically you're giving the laser operator or someone the actual means to make decisions to maximize flow, maximize throughput through the shop, using the information that typically exists right on a job packet, the hours. I remember the first time doing this in the 1990s. It's like, oh, how are we going to know? And one of the operators says, it's on every job packet, the number of hours. It's right on there. And I was like, oh, okay. So they created some visual signs or something that they would hang on to the carts where the jobs were being moved on. So anyone could look and see, yeah, that's 2 hours, and 2 hours is 4 hours, or it's something different. They just created some visual signage, basically, for each job to know that you could look at a queue and see immediately how many hours is in front of that. And this can be expanded lengthwise to include other operations. It can be included to include multiple brake presses, multiple welders. So a laser operator might not put it in a one brake press person's queue because they're full. The status of the queues would indicate that they would go to a different brake press. So it's all that decision making that often is not done, or not done in a timely manner, or done by someone not as close to the work as possible. And here, if we set this up properly, the operators themselves could do this. They could manage this for themselves. Here's an example of one. It's a stone fabricator. I mentioned I've worked with several stone fabricators in the past. And the way their constraint was finishing, kind of the end. Doesn't always work that way. The soles up front could outrun anything. Once in a while, the CNC machines could become constrained based on the mix of jobs. So you'll see that they added an element of that to it. But typically, it was the finishers that are the constraint. They're using a color-coded cart to be sort of their signal, and that controlled the release of work, controlled the amount of work in process that existed in the system at any time. We had to keep things simple, one job per cart, and that was a struggle for them because they used to not have enough carts because they were pushing too much whip onto the floor. I'm not going to hit all these things, but basically, if you didn't have an open cart, that stopped you from either at the saw cutting more or any process doing more, if the downstream process just was not ready for it. So they had to take this board, the different job tickets, job packets, and that was, again, at the finishing area, what they called the benches. And once they finished up their job, they went to the board, they would take the next job, and based on the status of the supplying processes, like the CNCs or the Pro Edge, or maybe there was no machining needed, they would be able to choose the right job based on, the work queue of those supplying processes. So as I mentioned a moment ago, sometimes the CNC would be backed up. It could become temporarily constrained, and we certainly wouldn't want to just run or trigger the next job for CNC if we had other jobs that we could run that would bypass that constraint at that time. So that was all done by this board. Then they would pick the color part and bring it up, and again, the colors had meaning based on the type of supplying process like CNC. They had to work out the numbers. And this allowed also some timely decision-making by folks of what to work on and when to work on it. The saws were at the very beginning. The sawyers could look at the different empty carts. So this is all demand for the saw. And they can see that the red one is there's 2 parts for them. Therefore, they're probably running lower on work, and the sawyer should choose to run that job as they get the ticket. So the tickets, again, coming from finishing, but then these things kind of pile up, and then the sawyers can make more timely decisions on what they want to run next based on really the status of the queue of the next process, the CNC machines, for example. So once again, it's all driven by the back end. It's triggered by the carts with the job tickets on the cart, a little bit of color coding to help for more, I don't know how to say that, but more, a little better decision making from job to job, really, to help maximize the flow and the throughput for that system. Some more on pull systems and combines. To a large degree, job shops are doing this. You don't have finished goods inventory. You're making to customer order. So we're just talking about taking that and applying similar concepts for to control work in process, controlling the flow of work from maybe the office to production. We put pull systems up for those to trigger the job packet creations. So it's just a matter of taking it upstream from what you're already doing with finished goods. Certainly you can do this with your purchase materials as well. And because it's really a decision system, once it's on pull, it's kind of, one less thing to worry about. Proper decisions are being made at the proper time most often. All job shops need to have excellent workplace organization, and that's where 5S comes in 5S'ing everything. Tools, equipment, the information, and both applying it to office and production environments because the office is usually so important in a job shop. And people struggle with this. In particular, the 4th S is standardized. But we can standardize work in job shops. What you need to think about is the decision process that people are going through and standardize that. Yes, the output can be very different and vary every job, but the process themselves are very similar, and the decision processes are very similar. It's just a matter of extracting that knowledge out and putting it in a form that others can use, like a very, not just a checklist, but a checklist that kind of represents the decision-making process. So when people tell me, we can't standardize, we're a job shop, I'm like, yeah, you can. It's going to take a little more creativity and a little more work to do, but you can do it, and you shouldn't accept anything less because you need to be very, very organized. Your businesses, again, are complex enough to deal with disorganization. So here's some examples of that. this is a visual device on the right here that is for a job shop, and each of these is a different machine. And we may run all these machines today or this shift, based on the job mix. We might not run them all. And one of the struggles that this company had was getting the right people in the right place every shift. People would show up for work, clock in, go to the machine they were at yesterday, until a supervisor said, no, I need you over here today. I need you over here, for the next couple hours. It was a lot of air traffic controlling. So what they did is they created this device, and what this is, each of these machines, and then these are all little magnets with people's names and the skills that they presently possess. So what happens now, before people arrive, before the beginning of the shift, is the supervisor looks at the schedule, knows what they have to run, how many people are needed to run those machines for that type of job and those quantities, and then can actually set this board up before anyone even shows up at the beginning of the shift. There are other roles you'll see on here. We won't get into those today that are in support of the production machines equipment that the rest show. And, so now what happens is people show up, they clock in, they actually have a huddle. This board is to one side or the other. After the huddle and review of, what the goals are of the day, there's obviously some tweaking that has to be done based on absenteeism. But generally speaking, they can get up and running, including a 10-minute huddle, within about 15 minutes. It used to take them about a half hour without a huddle, without any sort of connecting with people on a regular basis. It took them a half hour just to get all the pieces in place to really start humming in production. So this is just one way of doing it. But using that information and knowledge of who can do what in the schedule, and then doing that in a very proactive way before the beginning of the shift, setting up who's doing what. Once they get to the machines, there's a plan versus actual board at each. This example expands a little bit more in our conversation of managing time frame pitch, getting a tempo to work. It's under the umbrella concept of plan versus actual. This actually is for an office environment where this is a job ticket, and this is going to run at Monday at 7 o'clock, and then Tuesday on the right, Wednesday, Thursday, Friday, Saturday. This, more importantly, what I'll point out here is, notice the hour-and-a-half increments on the left-hand side. This job shop printing company, every hour and a half, reviewed flow of jobs through the office and the shop every hour and a half, and made adjustments as necessary if they had a problem. The fact that this job ticket is tilted is a visual indicator that something's not right. And since this is pre-press, pre-production, something is not flowing right with this job in pre-press. And then every hour and a half, there's a brief meeting, and they all look at this board in an open office environment. If all the job tickets are, okay, the meeting's over in seconds. But in this case, somebody would have a conversation. What is wrong with this job? What do we have to do to get this back in flow? And who's going to go follow up on that? So every hour and a half. Now, put that in context. They have a 3-day lead time. 1 day pre-press, 1 day on press and bindery, third day is ship. All right, so they're looking very, very frequently at the flow of jobs. Here's a different example of a plan versus actual. We call this a floating pitch board because job shops don't make the same thing. They're running different parts and at different quantities and different cycle times for those. We would take that information, typically on a job ticket, lay out a schedule, not a schedule, but a cadence board for the machine or machines that are running this, or a cell, if we're set up as a cell. It's basically, the plan is by 7 o'clock, I should have 50 job A's done, and then what is my actual? And you just have this plan versus actual going through the day. And you can do this by hour, you can do it by 2 hours. I've seen people do this by half hour. Depends on what you're trying to accomplish. And very importantly, you get the benefit of setting a cadence to work. Management, leaders can see very quickly if we're ahead or behind. And very important on the right-hand side here, the comments, getting people to put what their problems are. And as we see recurring comments, recurring problems, then that can trigger some improvement cycle, maybe like applying total productive maintenance or TPM on this press if we see every couple of days downtime on press. So we can drive some improvement, which will help us in more longer term. That's what we call a floating pitch board. So that's basically what I wanted to cover today. A lot of content. Last, I just want to summarize the typical approach that we take with job shops, and this is true of metal fab, stone fab. It doesn't really matter. Is really look at your products and identify the families. And by families, we mean groups of products that share similar processing steps. And sometimes it could be, we did 2,000 different products last year, and we look at all that, and we're looking at the processing steps, and you start seeing themes, groups of products that share similar processing steps. And that in of itself, that exercise helps people start grasping their business and seeing it through simpler eyes. So again, it's a complex business already, and it's very easy to get overwhelmed by the complexity. To start seeing those similarities, we do step one. Step two, we do value stream maps, and it's not just of the manufacturing area. It's all those processing steps from quote to cash, basically. So it takes us from quoting and order processing, estimating, maybe as part of the quoting process, all the pre-production office processes to prepare, all of that. And what we see there very often is the poor information quality, the low information quality metrics. And that tells us we have to work on that. But it might show us other major obstacles to our objectives as well. So we always suggest do a value stream map. And it's not easy to do in a job shop. You do it by product family. Once in a while, one family fits all. But usually you're going to do a couple maps. But it's great learning. It's a great collaborative tool. And we strongly recommend doing that early. Then very quickly to get that visibility, we want to put in a capacity planning tool with the appropriate management time frame. How far out should we look? How far out should we fix the schedule? Is it a day? Is it a week? What can we put in place to monitor the plan versus actual and see are we on track or not? Is it every hour and a half like the printing company or every hour like that pitch board showed? So that's step three, because that is very important information for organizations to have. They can, again, start feeling they've got control over what's happening or can have control over it. A lot of this, what comes after this, really is based on the results of the value stream map. But generally speaking, we have to address the information quality as soon as possible, because without that, you're kind of fighting an uphill battle. We try, put the basics in place of 5S, which can include total productive maintenance if there's equipment reliability issues, because you can't have much of a plan if you're always fighting with equipment reliability issues. If necessary, applying the quick changeover concepts to give us more flexibility. And then maybe think about revising layouts to support flow either in office or the shop. But we've got a lot of work just getting us through steps 1 through 6 here before we start thinking about 7. 8, actually, we can do relatively quickly with layouts as they exist. It's not as easy, but it can be done. So very often we're trying to, not push the work or the jobs to the next step or to the shop unless they're ready to take it. So we might just put some basic pull systems in place, even without changing the layout. As time goes on, as I mentioned a couple times, the role of sales becomes very important here. So we've got to now tie them into all of this. So that has to all be worked out in a form of sales and operations planning mechanism. And once again, the proper frequency for that has to be figured out. Is it daily? Is it weekly? And then it's a matter of continuous improvement after that. You set up your key metrics, whatever those are, on-time delivery, maybe order to cash lead time, whatever is important. And then just driving continuous improvement of those metrics over time. So that's the general approach that we take. There's no set recipe for all businesses, so we have to be flexible for sure, and we definitely have to adapt the concepts to each business's specific circumstances. That's pretty much the presentation. I think we've got about 6 or 7 minutes for questions, if there are any.
Thanks, Drew. Just a reminder, if you do have a question for Drew today, you could submit it through the chat box. Another reminder, if you missed any of today's webcast, we will have it archived in about a week's time on www.thefabricator.com, and you will receive an email notifying you when it is available for viewing online. Drew, looks like we do not have any questions, so I will
That's remarkable, Andy.
Yeah, you've covered everything, so I'll turn it back over to you for any closing comments.
So just remember, again, I've said it several times, experience is data. You know, that knowledge and experience you have in your organization is really significant. And it's just a matter of extracting that information out of the folks that have it and putting it somewhere that can be tapped by others. Someone's asking the question about how do these topics apply to Epicor? Well, it's an information system. So a lot of times the information does reside in these systems or can reside in these systems that can make it much more accessible to others, particularly like information on quoting and estimating, where people are maybe doing that on the road. So that's how this all ties in with Epicor or any information system. You know, it's all about getting that information and having access to it once it is obtained and collected. I don't know if that answers Michael's question on how does this apply to Epicor.
Yep, I think we're good. Looks like nothing else in, Drew, so looks like we're okay to wrap her up.
Okay, thank you all.
Thank you. Ladies and gentlemen, this does conclude today's webinar. We thank you for your participation. You may disconnect your lines at this time and have a great day.